This is the fifth and last video of looking at the notes for random variables and probability distributions that go with those random variables. So we're going to be looking at example 4. This is actually, I believe it's problem 2 from the homework section, from section 14A. But I wanted to do this example with you because there's another problem in your set that you're going to be assigned that's kind of similar. All right, so this says a fair-sided die has a 1 on one face, a 2 on two of its faces, and a 3 on the remaining 3 faces. It says the die is thrown twice, and T is the random variable, and it stands for the sum of the scores from both throws. And we want to find the probability distribution of T. So again, on a problem like this, where we have, two things that are going on and we have to do probabilities of various things, a tree diagram is probably the easiest. So we're going to have our first roll and our second roll. And we want to make plenty of space for ourselves on the tree diagram. So let's have the possible outcomes 1, 2, and 3. And then we know that off of each of those, for the second roll, we have 3 outcomes, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so the probabilities are, remember that this die only has 1 1 on the face. So 1 1. It has 2 2s, and it has 3 3s. So the probability of getting a 1, if it only has 1 on the 6 sides, is 1 out of 6. Probability of getting a 2 is 2 out of 6, and the probability of getting a 3 is 3 out of 6. And remember that these values that you put here should add up to 1, and they do. Right, then it's going to be the same thing here. We still have the 1/6, the 2/6, and the 3/6. 1/6, 2/6, 3/6, 1/6, 2/6, 3/6. Okay, then what we want to do is go back and see what our random variable was again. And random variable T, remember, is the sum of the scores from both rows. So on the first one, we have a 1 and a 1, and so the value of T, the value of T is going to be 2, because I'm going to add them up. So I get a 2 here. On the next one, I have a 1 and a 3, so that's going to be 3. A 1 and a 4, so that's 4. The next one, I have a 2 and a 1, so that's 3. A 2 and a 2, and a 2 and a 3. And then the last one, I have a 3 and a 1, a 3 and a 2, and a 3 and a 3. All right, but if we need to make a probability distribution for this, we need the probabilities that all of those are going to happen. So we're just going to do probabilities here. Let's do a different color. So probabilities. And that just comes from multiplying. So we've got 1/6 times 1/6, or 1/6 squared. The next one, we have 1/6 times 2/6. The next one, we have 1/6 times 3/6. All right, for the 3, 2/6 times 1/6. For the 2 and the 2, or for the 4, we get 2/6 times 2/6. The next one, the 2 and the 3, is 2/6 times 3/6. And then the last one, we have 3/6 times 1/6. 5, we have 3/6 times 2/6. And then to get the 6, 3/6 times 3/6. All right, so if we just then multiply these out, make it a little bit better, we get 1/36, 2/36, 3/36. The next one is 2/36, 4/36, 6/36. I know it's getting hard to squeeze this in. The next one is 3/36, 6/36, 9/36. All right, so now we note that t can take on the values 2, 3, 4. We've already got those 5 and 6. So let's make the distribution for that. So we have our value t, our variable t, and it can take on the values 2, 3, 4, 5, and 6. And we want the probability that t equals each of these little values of t. So for the 2, there's only one way to get that, and that is 1/6 squared, which is 1/36. So we have a 1/36 here. To get a 3, there are a couple different ways we can do that. We can get it here, here, and that's it. So notice that that's 2/36 plus 2/36, so that's 4/36. I'm just going to leave these unsimplified because we want to verify that they actually add up to 1 when we're finished. To get a 4, a couple different ways you can do that, but it's 3/36 plus 4/36 plus 3/36. So when we add up those, we end up with 10/36. To get a 5, there's two ways. There's a 6 out of 36 and a 6 out of 36, so that's 12 out of 36. And then the last one, to get a 6, 9 chances out of 36. So that's the first part of the question. The second part says, okay, so now what's the probability that the total score was more than 4? Well, once you have this set up, to do, for this one, the probability that the score is more than 4, you're saying I want the probability that x is greater than 4. So that's going to be the same as the probability that it is either a 5 or a 6. So it's going to be 12/36 plus 9/36, which is equal to 21/36. If I divide both by 3, I get 7/12.